This is question 41 from the GATE 2016 session 3 EC paper, where we are given this circuit and are asked to analyze it in small signal and to find out what V out by Vin, that is the voltage gain of this circuit is. We are asked to assume that the transistors have non-zero channel length modulation but have negligible body effect. Underneath the question, you will find the title of the NPTEL course or video relevant to this topic. Before we start, a little bit of background. Shown here are a PMOS and NMOS transistor and their equivalent small signal circuit representations. So let's start with the solution of this problem. First, we replace transistor M1 by its small signal equivalent. So M1 has a VGS as so, which I'll call V1. We have the input signal Vin and across it is V1. M1 has the equivalent as GM1 V1 in parallel with R01. This has this as its small signal equivalent. This is now V out. We can ground the VDD supply because in small signal it will be a ground, which means, and also we can ground VG. So the VGS for M3, which I will call V3, is as so. And we have the current source for M3, which is GM3V3 in parallel with RO3. This is the small signal equivalent of this. Now finally, for the transistor M2, we will get that the gate to source voltage is as so, which I will call V2. V2 is between VDD and the output node V0, and you have a current source GM to V2 in parallel with RO2. This is the small signal equivalent of this. So clearly you can see that V3 is equal to 0, and so there will be no current through that source. We can simply remove it. If you have V and the current being GMV, then this is no different from simply a resistor of value 1 by GM, right? If you have V as the voltage across the resistor, the current I will be equal to V by 1 by GM, which is GMV. So you can see that element on M2. So this whole thing is simply a resistor of 1 over GM2. So now it's fairly easy to see what the circuit is. It is simply a common source with four load resistors. So redrawing more simply, we get Vin, V1, GM1 V1, and a resistor which is RO1 parallel RO2 parallel RO3 parallel 1 by GM2, and this node voltage is Vout. So what will Vout be? It will be minus GM1 V1 times RO1 parallel RO2 parallel RO3 parallel 1 by GM2. So Vout by this is minus G, and V1 is equal to Vin, right? So Vout by Vin is minus GM1 times RO1 parallel RO2 parallel RO3 parallel 1 by GM2. Thus, the answer is option C.